Hey, how's it going? All right. So, welcome back to another video with of Chem with Com. Today we're going to be continuing ions, periodic properties, and moles, or ions and periodic tables and moles. Um, Specifically, we're going to look at the periodic table, right? All right. So let's get going here. We left off doing ions, but we're switching to the periodic table. And so throughout this course and through chemistry, we'll be talking about a few things. One of them is going to be periodic table. And it's very important. It's very handy to use. If you know how to use the periodic table and know the different trends and kind of different columns and rows, life is going to be a lot easier for you in chemistry. All right. So let's classify. This is the whole periodic table. These are the classifications. We'll go through some other things, but let's start here. Um, these different color codings, this kind of beige or off-white or eggshell, these are going to be metals, right? And I'm going to try to box in these metals. All right, these are going to be the metals. See what kind of zigzags throughout here. All right, that's mostly the metal. Everything to the left, or everything under this kind of this box I just made, are metals. They have something called metalloids, right? That's these pink boxes here. Um, they're kind of like metals. They're metals sometimes, other times they're not. And then you have these non-metals, everything in green here, right? We're basically going to separate the whole periodic table into metals. And then everything that isn't metals, right? So metals, and these are going to be called non-metals, right? That's how we're going to separate this periodic table, metals and non-metals. Even though there are semi-metals or metalloids, right? We're not going to consider those metals. They're going to be non-metals, right? Okay, the word for today is gatito. So the secret word today is gatito. All right, so let's make the periodic table a little more manageable. Or sorry, this is the periodic table kind of groups or columns. Columns, right? The left are alkali metals, group one. Group two are the alkaline earth metals. The small box in the middle, they're called transition metals. 13 and 14 really don't have names. The more common ones here, we don't really use 15 and 16. We do use 17. They're the halogens. 18 are what are called the noble gases. So I'm going to circle the ones that are pretty popular, just so that we can get those. And we almost never use these in this class. I can't remember one that we do use from those rows or columns, right? So let's move on from here. And so this is kind of where we're gonna use, and I'm gonna draw our line again to separate the metals from everything that isn't a metal, right? These are gonna be the metals, and then everything else are gonna be the non-metals. I guess this is supposed to be metals, and then everything that isn't, which are the non metals. We'll group these together as the non-metals, right? Cool. All right. So periodic table, we have metals and non-metals. Let's take a look. Lithium. Lithium, a metal or a non-metal? Well, the symbol for lithium is Li. That's going to be a metal. All right. Chlorine. The symbol for chlorine is C with the lowercase l. It's over here. That's a non-metal. Hydrogen on the left side over here. But, and sorry, it's H. It's that green, and that's going to be a non-metal. Silicon, right? It's grouped as a metalloid or a semi-metal, but again, we're only grouping things into metals and non-metals. So since it's not a metal, it's going to be considered a non-metal. Sorry. All right, let's continue here. So we know metals versus everything else, or metals versus non-metals. All right. And we're going to use these kind of the first three rows. So again, these columns are groups. So columns are groups. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Over down here are what are called the transition metals. I don't want to use those now because we're not really going to, I don't want to show them because we're not really going to use them, but that's these, right? 3 through 12. And this is the new style of numbering. Before there used to be like Roman numerals and A's and B's, but now we just call the groups or the columns 1 through 18. All right, and then 13, 14, 15, 16. Again, these are the halogens, noble gases, whatnot. All right, the periods are the rows of the periodic table. Now we're going to see some similarities of elements within the same period. We're going to see similarities of elements that are within the same group, which in the same column, right? So it's going to tell us a lot of information. So let's pay attention to these different trends and what they'll tell us. Okay, let's go back to our original idea, ions. How are you supposed to figure out what ions something may or may not be? Well, we're going to use these different rows and columns, right? Or periods and groups to figure that out. And so what I'm going to be doing here is I'm going to be drawing what's called a energy uh, or it's an energy model of an atom or a Bohr model. So energy or Bohr model of an atom, right? And it's going to show energy levels. Oops, sorry. Energy levels, electrons, things like that. Maybe some protons. Oops. Protons, right? All right. So let's do hydrogen. Let's start with hydrogen. Hydrogen has an energy, atomic number of 1. So I'm going to put here it has 1 proton, right? And this is going to be the little nucleus, right? And that first, um, since it's a row or period of 1, period of 1 equals 1 energy level. So 1 energy level. All right, so I'm going to represent the energy level with a circle, right? So I'm going to say, okay, 1 energy level. And we're going to draw neutral atoms here. So if we have 1 proton, we're going to have 1 electron. Okay, so electron's not going to be in the nucleus. It's going to be outside the nucleus. So I'm going to say electron. And I'll just guess I'll draw arrows for this just so we can kind of annotate this and we know what we're talking about. Let me erase that little squiggle so that we know what we're doing. 1 proton, right? 1 proton, 1 electron, hydrogen. Okay. And we said because it's a period of 1, it's 1 energy level. Well, what's helium going to be? Is helium going to have a what period is helium in? Well, it's in the first period, the first row. So it's going to have 1 energy level. It's going to have an atomic number of 2. So it's going to have 2 protons. If it has two protons, it has two electrons. All right, let's go to lithium. Lithium now has three protons. So I'm going to draw three protons here, put it in the nucleus, right? It's in the row or period of two. So it's going to have now two energy levels. And I'll annotate that too. All right, so two. Um, so we'll say, let me get this out of the way here, but it's going to be uh period equals two. So we'll have energy levels equal two. Okay, but we have, I'm going to draw a little line here. We're going to have three protons. We're going to have three electrons. All right, so the first two electrons go in the first energy level. All right, so we have, right, because in the first row, first period, there were two atoms, hydrogen and helium. That first row or the first energy level can hold two electrons, right? So now the first energy level is completely full. So that means that third electron has to go outside or in the second energy level, right? I'm going to label this also. Let me get it in blue just so it's easier to see. Um, I'll label this. E is going to be energy. So energy level equals one. And that's what's called the core electron shell. All right. That's the core electron shell. The outside shell is called a valence shell. So this is a valence electron shell. Valence electron shell just means the outside electron shell or a level. Valence electron shell or energy level. This is going to be the outside. All right, let's continue. We'll do this enough times so there's a trend. Beryllium, there's four protons. We're on the second row of the periodic table, so we're going to have two energy levels. So we're going to put four protons, so we should have four electrons. So two go on the first energy level, and then two more go on the outside, on the second level, right? So I'm just going to mark these one and then two. This is energy level of two. This is an energy level of one. All right, boron, five protons, because we're still on the second row of the periodic table, so there are two energy levels. So again, two electrons in the first energy level. There's going to be now three for a total of five electrons total. All right, carbon, six. So there's six protons, there's six electrons. We're still on the second row of the periodic table, so that means there should be six total electrons, right? Because six protons, six electrons. This is energy level of one, energy level of two. One, two, three, four, five, and six. So again, these are energy levels. They're not actually where the electrons are. This is just representing the levels of energy that these electrons are sitting at. And again, these are I'm going to do this in blue. These are the core, and I'll probably erase some of this stuff because this is the valence electron shell. So a valence electron shell. This is the outermost shell. And this is the core, or these are the core because there's two of them, right? Core electron shell. So basically anything on the inside. And I'll erase some of this stuff so it gets it out of the way so we don't have too much congestion there with all this writing, right? It's a little cleaner. All right. So then let's go to nitrogen, 7 protons, 2 energy levels because we're on the second row of the periodic table. I'm going to label this energy level of 1, energy level of 2. We have same thing, 2 core electrons. We have 5 valence electrons. 1, 2, 3, 4, 5. Oxygen, 8. We're going to do 1 and 2. So we'll have an electron here. So we have used up 2, so we need 6 more. 1, 2, 3, 4, 5, 6. All right, fluorine, 9. 9 protons. Again, second row, 2 energy levels, 1 and 2. So we have first energy level, second energy level. This time, the second energy level is the valence shell. Okay, so let's figure out what's going on here. We have 2 core electrons, and then we're going to have 7 valence electrons. 2, 3, 4, 5, 6, and 7. Neon, we're going to have 10 protons, 2 energy levels because we're still on the second row of the periodic table. So 1 and 2. We have 1, 2, 10 total. 3, 4, 5, 6, 7, 8, 9, and 10. All right, we got 4 more to go. I know it's kind of tedious, but repetition is very, very good for chemistry. You need to do a lot of repetition. Sodium, 11 protons. Now check this out. We're on the third row of the periodic table. So we're going to have now 3 energy levels. So we'll say third row, 3 energy levels, right? Here we have period of 1 energy level. Period of 2 energy levels. Period of 3, a row period, sorry, interchangeable to me. 3 energy levels. All right, so we have to have 3. This is our first one. This is now our second one. This is now our third one. All right, so let's fill up these energy levels. We have 11 electrons total. I'll mark this 1, 2, and 3. All right, 1, 2. We can only hold 2 electrons in the first energy level. Well, how many atoms are there in the first row? 2. So we can hold 2 electrons. How many atoms in the second row of the periodic table? Well, there's 1, 2, 3, 4, 5, 6, 7, and 8. So we can hold 8 electrons in the um, second row of the periodic table. All right, so let's look at this. I cut out some of these middle ones, but I just wanted to show you a couple trends here, but let's go. So we can hold 8 electrons. 1, 2, 3, 4, 5, 6, 7, and 8. Now We have 10 electrons now. We need 11 electrons. Where's the 11th electron going to go? If the first row is the first energy level is full, the second energy level is full, so the third energy level has to take that other electron. Okay, so let's do this now. Let's do magnesium. It's 12. I'm going to go a little faster because we know the basis for this. 12 protons. We have three energy levels because we're in the third row of the periodic table. And I'm going to draw all these here. All right, so let's do this again. We have one, two, and three. We have 12 total. We can only hold two electrons in the first energy level. We can hold eight in the second. So two, three, four, five, six, seven, and eight. Okay, we have 10 total. We need 12 if the first energy level is full and the second energy level is full. We have to put those other two electrons in the third energy level. And let's do chlorine. Now let's skip all the way to chlorine. Let's see a trend here. Okay. All right. Um, and I'll kind of be flipping back and forth, but let me do this in green. Okay, we have one valence electron. Here we have one valence electron. Here for sodium, we have one valence electron. So everything in the first column has one valence electron. So one valence electron. Let's look at the second column, two. All right, second column, two. There are two valence electrons. Magnesium, column two, two valence electrons. Cool, right? So because we're in the second column, it has two valence electrons. Um, Boron has three. So three valence electrons. One, two, three. And everything below boron is going to have three valence electrons. This is going to have four valence electrons. This is going to have five valence electrons. This is going to have six valence electrons. This is going to have seven valence electrons. Let's check it out. Let's do chlorine. Chlorine has 17 protons. It's gonna, third row, it's gonna have three energy levels. I'm gonna guess that this one has seven valence electrons because fluorine has seven valence electrons. So this is, again, third row. This is gonna be the three energy levels. So we have one, two, three, four, five, six, seven, eight, nine, and 10. All right, we need seven more. If the first and second energy levels are full, we're going to have to put it in the third energy level. So let's say one, two, three, four, five, six, and seven. Let's count them. So fluorine has one, two, three, four, five, six, and seven. Chlorine has one, two, three, four, five, six, and seven. Wow, that's cool. And we're going to have same thing here. We're going to have eight. Oh, sorry. This is two valence electrons for helium, but here for neon and below, I'll put just a line here. This is going to have eight valence electrons. Here we have one, two, three, four, five, six, seven, and eight. Let's do argon for one last one. 18. It might be a little squished here. I didn't leave us enough room, but let's see how it goes. All right, we have one third energy level because we are on the third row. So I'm just going to put a E1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, so we need eight more, which gives us the eight valence electrons, but let's do it anyway. One, two, three, four, five, six, seven, and eight. Let's count them again just to be sure, right? We have one, two, three, four, five, six, seven, and eight. So cool. This is eight valence electrons from neon down. All right, so let's fill in this table here. So we'll say valence electrons. Everything in group one is going to have one valence electron. Everything in group two is going to have two valence electrons. That's what we saw, right? For beryllium and magnesium, we had two valence electrons. Boron was three valence. This is, so let's just put it here, valence electrons, both sides, I guess. We'll scrap this because it's a little squished over there. All right. So valence electrons, this one is going to have four, five, six, seven, and eight. And then just to keep this right, I'm going to circle this and say two valence electrons, right? But group one has one, group two has two, group 13 has three, 14 is four, 15 is five, 16 is six, 17 is seven, 18 is eight valence electrons. All right, cool. So there's a trend from the periodic table, periodic trend, right? Okay, so let's go back to here. All right. Now I want to point this out. It says main group atoms will want, quote unquote, eight electrons, or what's called a full valence shell. Full valence shell. I'm going to relabel these two in blue so that we'll see this. This here is the valence shell, right? Valence electron shell. These inner ones, so I'm going to draw a couple lines. These are the core electron shells. All right. So that's the core electron shells. All right, and let's move ahead here. I'm gonna, um, we're gonna kind of go back and forth between this slide. I know it's kind of busy, and I'm gonna try and free up some space on the next slide, but let's take a look here. All right, so we figured out from this that basically how many electrons or valence electrons these atoms have, right? And we have them listed here. 1, 2, 3, 4, 5, 7, 8. The only oddball for now is that helium wants two valence electrons, right? And then we have a rule, kind of a quote unquote guideline or rule that all atoms want full valence shell of electrons, right? But if you remember, these already have, oops, let me write that better. These already have full valence shells, right? Already have full valence electron shells. So we don't have to worry about that one, right? But we're gonna use this to predict the charges of these atoms. All right. Now I'm going to draw these without, I'm going to draw them kind of below. Let's use row 2 just as an example, all right? So this is lithium, so we'll say 2. Lithium has a positive 3 protons. It has 2 energy levels. Okay, so we're going to give it its 2 electrons in the first energy level. Let's label those. And then another electron in that second energy level. Beryllium now. Beryllium is a 4 plus. It has 2 energy levels. It has 4 electrons. All right. So boron, let me label these better. Lithium, beryllium. I'm gonna give myself a little space here. Boron, carbon, nitrogen, oxygen, fluorine, and neon. All right, so boron again is 5 plus 2 energy levels. So 1, 2, 3, and then 2 in the middle for 5. This is 6 plus, 7 plus, 8 plus, 9 plus, 10 plus. Again, 2 energy levels. I swear I'm going somewhere with this, not just drawing circles, but um it might be a little tight there. Like, let's do this. And then 1, 2, 3, 4. All right. So this is 1, 2, 3, 4, 5, 6, and 7. Again, they all have 2 electrons in their core. It might get a little weird over there on that side, but 1, 2, 3, 4, 5, 6. We're just repeating what we have here, right? This is 1, 2, 3, 4, 5. Let's just erase those. We get the idea here. I'm going to erase fluorine just because there's not enough room. We'll just work with neon, and show you that part, right? So 1, 2, 3, 4, 5, 6, 7, and 8. All right. So again, lithium has 1 valence electron, beryllium has 2, boron has 3, carbon has 4, nitrogen has 5, oxygen has 6, fluorine has 7, neon has 8. All right, and we were talking about row 2. Now, again, all atoms want full valence shells of electrons, right? So if I'm fluorine, I don't know why I scratched that out because I can't draw, right? If I have fluorine and I have 7 valence electrons, but they want a full valence shell of electrons, let's figure out what that's going to be. So this is going to be what's called the predicted charge. All right, if it's starting at 7, but it wants 8 electrons, it's going to pick up 1 electron. So let's do this in blue, I guess. So plus 1 electron, so it equals 8. That's going to be an extra electron. So that's going to be a fluorine 1 minus, right? Because we're trying to get to 8. Or for this row anyway. For the first row, we're going to get to 2. So this one starts at 6 electrons, but it wants 8 electrons. So it's going to be 6 plus 2 electrons equals 8. So that's going to be, since it's a 2 electrons, it's going to be oxygen 2 minus. Now I'm just going to draw underneath here um, the ion, right? So let me go back and just kind of reset this, right? So the predicted charge for this one, maybe let's swap those numbers out. Let's just say ion. So in the predicted charge, right? So this is ion up here, and they'll say predicted charge, right? This is going to be a um, oxygen or fluorine of a 1 minus. This is oxygen with a 2 minus. Nitrogen, right? Um, Actually, let's skip over here to lithium. Let's do lithium now. Okay, so lithium has a couple options, right? Lithium is either going to pick up 7 electrons, right, to get to 8, or what it could do is it could lose an electron, right? So do you think it's easier for lithium to lose a single electron, or is it easier for lithium to find 7 electrons? Well, atoms are going to do what's easiest, and it's easier for lithium to adjust 1 electron instead of adjusting 7 electrons. So lithium is going to actually lose 1 electron, and now it's going to have 0 valence electrons, right? Because if you lose these 2 electrons, this is your new valence shell, right? If there's nothing on the outside, that inner one now becomes your, oops, sorry. It's only supposed to be that one. There you go. It's only supposed to lose that one, right? Because we're only subtracting one. So now it's going to be lithium 1 plus. So it's going to be a 1 plus predicted charge. Over here, the oxygen is going to be a 2 minus predicted charge. This is a 1 minus, a 1 minus. Right? What about beryllium? Beryllium has the choice to pick up 6 electrons to get to 8 or to lose 2. It's easier to lose 2 electrons, so we're going to subtract 2 electrons. That's going to equal 0. So beryllium, just like losing these, right? It's going to be a 2 plus. So the predicted charge for the second column is 2 plus. Let's do nitrogen now. Nitrogen can either pick up 3 electrons to make a total of 8, or it can lose 5. Well, it's easier to pick up 3. So that's going to be nitrogen 3 minus. So the predicted charge for nitrogen is going to be 3 minus. Let's do boron now. Boron can either lose 3 electrons or gain 5. So it's easier to lose 3. So we're going to subtract 3 electrons, and that's going to have a 0. Let's look at this. 1, 2, and 3. So now it's going to be boron 3 minus 3 plus. Again, pluses are cations, negatives are anions, right? So this is going to be a 3 plus. Now, carbon's a little weird. Carbon, it's even. Is it easier to lose 4 or easier to gain 4? About the same, right? So we're going to just put a question mark here. We don't know what that's going to be. All right, so first column has 1 valence electron, and the first column, this predicted charge is going to be a 1 plus. Sorry, let's not circle that because we were using circles for something else. Let's box it. All right. Second column has two valence electrons. So that means beryllium and magnesium. And the predicted charge is going to be 2 plus because it's easier to pick up lose 2 electrons than it is to pick up 6 electrons. All right. So third col 13, column 13, right? We know there are 3 valence electrons. And so the predicted charge is going to be plus 3. We don't know for column 15, 5 valence electrons. So it's easier to pick up 3 electrons, which makes it a 3 minus. All right, 6, column 16, 6 valence electrons. These are always going to be 2 minus the predicted charge. All right, column 17 or group 17, that's going to have 7 valence electrons and it's going to have a predicted charge of 1 minus. Now, neon, argon, helium, they all have full valence shells. So the predicted charge for those, 0, because they're happy. They're not going to gain or lose electrons because they're perfectly happy the way they are, right? If you're not happy and you want electrons or you want a full valence shell, you're going to change or move around or do something to get out of your current situation, right? And yeah, so the secret word today is gatito. So secret word today is gatito. All right. So again, these are important. You want to make sure you write down how many valence electrons in each column and also the predicted charge for each column, right? We want to make sure we have that. All right. And just when we annotate these, I've been showing you kind of how we do this, right? And this is the chemical symbol and annotation for helium-4. It's always going to have 2 protons. And since it has a mass number of 4, that means it has 2 neutrons. Magnesium, same thing. Atomic number of 12. This specific one has 12 neutrons, so it's a mass number of 24. But when there are charges, and these are neutral. So we're here, we're going to put no charge equals neutral. Same thing, no charge, neutral, right? But when we have charges, right, helium has 2 protons. Oh, sorry, yeah, 2 protons, but it has a +2 charge. So that means it has 0 electrons. Charge. And since it's a positive, it's a cation. This is the same setup. Let's do something with a negative. Let's do something like fluorine. Let's do oxygen. Oxygen. Let's say we have oxygen. Let's do 17 just to make it fancy. Wait, oxygen is an atomic number of 8, so it has 8 protons. So this oxygen has 8 protons. It has 9 neutrons, and it has 8 electrons. Right? Let's do another oxygen. Oxygen 17, 8, but now a 2 minus, which is its predicted charge. If you look up here, remember oxygen, column 16, it's always, almost always going to be a 2 minus charge, meaning it has 2 extra electrons. So we're going to say here it has 8 protons. It still has 9 neutrons. But since now it has a 2 minus, which means it picked up 2 electrons, this is going to have 10 electrons. All right, so let's continue here. Let's do this. Write the symbol, atomic number, and mass number and charge for calcium with 18 electrons. Look on the periodic table. Calcium is Ca. Atomic number is 20. Mass number is 20 plus 18. Sorry. Um, let's actually, I didn't give you 18 electrons and let's say 19 neutrons. And this is nitrogen with, let's say here, 7 neutrons. All right, so mass number is 20 plus 19. That's going to be 39. And we have to figure out the charge. So let's do the first part of this, right? So we have calcium. It's a 20 here, which is the atomic number, and a 39. Well, let's figure this out. This has 20 protons. So we'll say 20 pluses. And it has 18 negatives. Right? So that's going to be now 2 positive, right? Because this is a cation. So this is going to be a 2 plus. This is it. All right, let's do this other one. Nitrogen, atomic number for nitrogen, look on the periodic table, is 7. This is 7 plus 7 equals 14. So it's going to be nitrogen with the 7, 14. But now we have to figure out the charge because it has only 10, it has 10 electrons, right? So we have 7 protons because that's the atomic number. We have 10 electrons. So it's going to be now a 3 minus. All right. So this is just showing the predicted charges, right? Group 1 is all a 1 plus. Group 2 is all a 2 plus. Group 3 or 13 is going to be a 3 plus. 14, we said we don't know. 15 is going to be a 3 minus, 3 minus, 3 minus. 16, 2 minus, 2 minus, 2 minus, 2 minus. 17 are all 1 minus. 18 is all going to be no charge. Now, we're going to emphasize this later, but 2 other ones you should know for this class is that the charge, the predicted charge for zinc is always going to be 2 plus. The predicted charge for silver is always going to be 1 plus. And I remember that just using a step, like a kind of, this is like the stairs, right? We know aluminum is going to be 3 plus because of its position in the periodic table. If you take a step down, it's going to be 2 plus. Take another step down, it's 1 plus. So everything here, you'll be expected to know the predicted charges. And if you can just remember that, hey, the columns will tell you what the charge is, it makes it a lot easier. The only one you have to really remember is 14. We're not really sure. And then zinc is 2 plus, silver is 1 plus. And basically it's if you're going from silver, zinc to aluminum, it's 1 plus 2 plus 3 plus. If you're going backwards, it's 3 plus 2 plus 1 plus, right? So just remember that this is kind of like a stair step, and you'll be kind of asked to know that for exams and things like that. All right, let's predict the charges of these. So magnesium is in the second column, so that's going to be a 2 plus. So it's going to look like this. Magnesium, 2 plus. Fluorine, 17th column. Or let's say group to make it more fancy, right? They're all going to be a 1 minus. So this is going to be fluorine 1 minus. Krypton, that's going to be an 18th group or column. And if you look over here, right, it's going to be krypton is no charge. So we're just going to leave it like that. We'll say no charge or neutral. All right, let's do this last one. Combine atoms of magnesium and fluorine to make a neutral compound. The charges have to add to zero. Let's do it over here in this little box. All right. The normal charge of magnesium is 2 plus. All right. The normal charge of fluorine is 1 minus. Well, we have a 2 plus and a 1 minus. That's going to equal a 1 plus. So not neutral. So now we have to add either a fluorine with another 1 minus or a magnesium with a 2 plus. Let's try another magnesium. Let's say magnesium 2 plus, magnesium 2 plus, and F1 minus. That's going to be 2 plus, 2 plus, 1 minus. That's actually going to be 3 plus. Not neutral. So that can't be it, right? Let's put an X by it. Let's try adding another fluorine. So we'll say magnesium 2 plus, fluorine 1 minus, fluorine 1 minus. That equals a 2 plus, a 1 minus, and a 1 minus. Well, we have two negative charges, two positive charges, so that's going to equal 0. So this is going to be correct. So the way you would write this formula is MgF2, because this 2 directly, the symbol, chemical symbol right next to the number tells you how many there are, right? So 2 fluorines, 1 magnesium, 2 fluorines. All right, so this is the correct formula. It's going to be MgF2, and that's a neutral compound. We're going to go through these next time, but these are called polyatomic ions, right? These are ions because they're charged, and polyatomic means more than one atom. More than one atom, and ion means with a charge. All right, well, that's it for today. Thank you very much, and I'll catch you next time. Yeah, thank you.